Matt's worked in Hydro for just about 10 years. He's directly involved in the design, construction, testing, and commissioning, or has been, of dozens of digital governors, ranging from 1 megawatt to 450 megawatts, all types: Francis, Kaplan, Impulse, Pump Storage. He's a member of the IEEE Hydropower Subcommittee, and he's also on the Western Electricity Energy Coordinating Council Model Validation Work Group, coming up with the models for the governors that are used in the grid simulations. He's currently engineering and operations manager for American Government. That's probably why you've been so busy. You get 2 hats now. He's a Bachelor of Science in Mechanical Engineering from George Washington University. He's authored numerous papers and articles, and he was also named, a couple years ago now, International Water Power and Construction magazine named Matt as one of the 30 under 30 emerging leaders in hydro. So with that, I present Matt.
Alright, so I'm going to give you a little bit of background on a project we're currently working with in New Zealand with Mighty River Power. Is anyone here from New Zealand? Don't hold me up with my pronunciations. Okay, so Mighty River Power was established in 1999 after the breakup of the Electricity Corporation of New Zealand. They're one of 3 state-owned generating companies, and they own 8 hydro stations on the Waikato River and on the North Island. So the plants that they own are Karapiru, Arapuni, Waipapa, Maraitai, plants 1 and 2, Whakamuru, Atiamori, Akahari, and Tiatia. So they have, the plants were built between 1920 and 1970s. The governor equipment was installed between the 1920s and the 1990s, and they have a broad range of governor manufacturers and types. They have stuff that I've never seen before, maybe some of my colleagues have, but English electric mechanical governors, no-hab analog electric governors, Boving mechanical governors, and more recently near-pick digital governors. I don't think they have one Woodward governor, one Pelton governor, one of anything you've seen here. So it's an interesting collaboration of the existing older equipment. And they have both Francis and Kaplan units. So several years ago, or leading up to several years ago, Mighty River Power realized that they're coming up to requiring a complete modernization of their governor control systems. They've experienced long duration outages due to operational failures of their systems. They've had a hard time maximizing their ancillary market revenues. New Zealand being a small island grid, puts great value and rewards that response of frequency regulation and reserve response. They've seen reduced capacity in some of their plants due to the current condition of their equipment. And as we're seeing here in the United States with NERC, they're seeing similar increased regulation and enforcement from the EIPC, or the Electricity Industry Participation Code of New Zealand. So they're looking for an approach to address these various concerns that they have, and they're looking for a standard approach that they can implement across their entire 8 plants. So where we come in is we were invited to participate in a tender from MRP April of last year, starting with 2 plants, the Atiamuri Power Station and the Maraitai 2 Power Station. And the scope of the project would be to provide new digital controllers, new hydraulic power units with servo motors, which would give improved performance, diagnostics, and remote controls. MRP operates from a central control station in Auckland. The other plants are several hours away, so remote control, remote diagnostics are very important for them. And then because they wanted to do this once, and because they wanted to design this once, they wanted a standardized design that they could roll out across their plant. So we're starting with 2 units, 2 plants, going to 2 plants after this, and then based on the success of the project, doing the remaining 4 plants. So I'm not going to talk about the technical part of the project, putting in new digital controllers and new hydraulic power units. There's nothing that technically difficult what we're doing here, but providing a standard product halfway across the world did provide some challenges both for us and for our customer. So we're dealing with multiple remote sites that are on a different continent halfway across the world. It's 3 o'clock in the morning in New Zealand right now. So we have a unique set of issues that we need to work through. There's different OEM equipment from 50, 60 years range installed. We're going to be providing new equipment and transporting that from New Zealand to New Zealand, from Australia to New Zealand, from the United States to New Zealand. And we're dealing with an international supply chain. And MRP is dealing with an international supply chain that they're not used to dealing with. So solutions to these challenges are, for all projects, planning ahead, examining our existing systems, and bridging the distance between here and New Zealand, utilizing local assets in New Zealand as much as we possibly can, and then coming up with a common design that's flexible and applicable to all plants and all projects. So planning ahead is particularly important here. We need to make sure that both teams are allocating the proper resources to the projects and the plants are allocating the proper resources to the projects. We need to do a very thorough design review. We want to make sure we have an approach that works for multiple plants, not all of which we're going to be seeing and working closely at the very beginning. And then we need a very detailed project schedule. They have a tight schedule. They have tight financial constraints and budget constraints, so it's common in most projects working with a tight schedule. So we started with examining the existing systems, working with the documentation when it exists. As you guys know, documentation from 1920 systems that were definitely not built in New Zealand is sparse and sometimes incomplete. Determining what the similarities between equipment is, determining what the differences between equipment is, and how that's going to play into a common design. And then working with a limited footprint. In all of their plants, we were dealing with a limited footprint and limited access. We had small access ways where the equipment needed to be transported through. Bridging the distance. It's hard to get things done on a timely basis working with New Zealand. You send one email, you wait a day, you get an email back, you wait a day. So scheduling meetings ahead of time, using video conferencing, teleconferencing, GoToMeeting, WebEx, things like that have been critical to this project. And then using local resources. We knew from the beginning that for a large part of this project, hydraulic power unit, we want to partner with a hydraulics integrator in New Zealand. So that was a big part of our initial design and project review. We worked with multiple integrators. Some visited us here, we visited some down there. We needed someone who we could trust to work directly with the customer when we couldn't be there. So we partnered with Rexroth out of New Zealand, and I'm very happy with them so far. They're 2 hours from the closest plant. We're 24 hours from the closest plant if you want to be there. So multiple times they've been able to go down, take a measurement for us, take a picture for us, and that's been critical to keeping things working smoothly as if we were working in the same country. We needed to design common equipment. We needed equipment that was readily available in New Zealand, or at least the Australasia region. We needed equipment that fit the footprints that they had, so we needed a lot of flexibility in our design, which I'll show you a little bit more about later. So the standardized governor package is a PLC-based governor, very similar to what James had talked about earlier. We have an Allen-Bradley-based PLC. We're based off the Compact Logic platform, which some of you guys may be a little more familiar with. Control Logic platform. It's just a little bit smaller, a little cheaper, but more than capable for the application. We have an local HMI by a company called Maple Systems. They make a very solid, small unit level HMI. You don't get the capabilities of a Wonderware or an iFix, but for a unit level, we control is perfect. It allows them to have remote interface through a VNC connection, so from their control room, they can see the local HMI on their computer through their closed network. And then we incorporate also a single application. So you have a single governor application that's applicable for Francis units, Kaplan units, that has information whether they're doing a high pressure conversion. Some of the units that will not have a high pressure conversion. It has capabilities to handle that as well. All within a single program where they can turn features on and off depending on what site they're at. So that definitely leads towards commonality in the software and commonality on the screens. So when operators go from site to site, they're familiar with the equipment. The one special feature we included, is the only one I'm going to highlight, is advanced diagnostics in the PLC. On board on the PLC, we have continuous buffering of data where we're sampling at 40 hertz. We can sample up to 1 hour of data. So, and we're capturing all I/O points, all critical control parameters, and all alarms and trips. And how this works is when a major frequency event occurs, or a trip occurs, or when manually triggered, we can capture X amount of time before the event and X amount of time after the event, pull that off through a SD card or a compact flash card, and read it as a CSV file, and it gives them a lot of the high resolution, high speed data that you can't get over sending data up to your Pi server or something like that. So the hydraulic power system, the idea was to, hydraulic power systems are more and less common. There's some specifics to the hydro industry, but more specifics are due to preference. So we met with their engineers, we understand their preferences, and we designed a common system. Because footprint was such a concern, we standardized on 2,500 PSI. That allowed us to minimize components as much as we can, while not having to go up to a higher class of pressures. So there were site-specific differences. We have several motor force differences. We have different equipment sizing, pumps, sumps, accumulators, but we have a common platform or a common layout. So this is a layout. It's a cabinet-style HPU. You have a sump in the back. You have redundant pumps in the front. We have a kidney loop pump. We have filtration, and we have a control manifold. So regardless of the site we're on, the pressure, the HPU will look just like this. It's going to be bigger or smaller, but your pressure gauge is going to be here, your control valve is going to be here, regardless of what site you walk into. And same thing with the accumulator bank. The number of accumulators you're going to have is going to vary depending on the speed of your servo motor and velocity of your servo motors. So we have a scalable accumulator bank. If they get large, they'll break down into multiple sections, specifically when we need to come through tight areas. So we may have one that has more than 7 accumulators, which is broken into 2 sections that then recouples together. And the two-piece approach, it gives us a lot of flexibility. We actually have our HPU control cabinet, our governor control cabinet, and our accumulator bank, all as separate pieces of equipment. And this allows us to fit in tight areas, put things around corners, and make sure that we can fit into the tight areas of the existing equipment. Some of these places, I'm convinced the concrete is poured after the equipment was put in. There's no getting fixing it out. Okay, so I'll talk briefly about the benefits of standardization and why MRP was trying to standardize. It's a more affordable approach. They're doing their engineering once. They're doing their engineering up front. That's applicable for all of their plants versus for each plant with each vendor and each plant's specific needs. You have a more developed design. You're putting more effort up front than honestly you would if you were just doing a one-off. It's just the nature of knowing that with your decisions you're making, you have to live with for the next 10, 30 years across all your plants. And you have more time to root out bugs and get to know the system. By the time you're doing the 3rd, 4th plant, you know that system well. You know what all the bugs have been worked out, everything's been proven, and the last units go in one after another, versus your first unit startup type issues every time. Common platform is easier to support and maintain. Your engineers, your technicians, your operators are familiar with the equipment. They're familiar with the parts. They're familiar with the screens. They're familiar with how the units operate. Your grid operators are familiar with how the units respond. You have readily available equipment. You know what parts you need. You know where your supply chains are. You know how to get them. You're not going to be surprised when things aren't available. And you have a reduced quantity of spare parts. You have spare parts that one part now works for multiple plants. So it's easier to maintain, cheaper to keep the spare parts, and it's easier to maintain your spare parts. So that wraps up the presentation. Thank you. Any questions?
We have like 30 seconds, so like one question. Hey.
Did you timestamp that data to GPS, or is it just?
Question is the data timestamp that they're collecting in the register?
On this project, we are not. It's locally timestamped, but there are other projects where we've timestamped over IRB or through DNP, and it's easily done as long as it's included in the bigger picture incorporated. It is hard to, you can synchronize the controller time, but all of the data we're collecting is onboard on the controller. We're not sending it out. So you would have a synchronized start time, but each data point's not being sent out independently for the timestamp. Thank you.